All right. Hi, everyone. Nice to meet you. I'm Philip. I'm one of the founders of Oak Security. And today I'm talking about how AI is powering audits, why we need AI in audits. Before we start, a little bit of background. Oak Security has been around as a boutique security auditing firm since 2017 in one form or another. We have 52 security researchers on board today. Have performed over 600 audits, and you can probably recognize a lot of these logos here. Personally, Brooke, thank you for the introduction. She just said a bit about my background. I think what I can add here is that I dabbled with AI before LLMs were a thing. In my master's thesis, I worked on natural language processing and how you can predict stock markets using tweets, so extracted sentiment, and use different AI models for that. Let's talk about vibe coding to just set the stage. We have recently had someone applying to become an auditor with us who is an anonymous developer from one of the top tier DeFi teams in the Ethereum space. And he said that his efficiency improved so much that he has too much spare time and he wants to do audits now in order to be not bored. It's probably a bit not exactly to the 10x improvement if he worked 40 hours before, he works 4 hours now. But it shows that someone who knows how to write smart contract logic, he can be extremely efficient with AI tooling. There's also a downside to this, which is that we receive a lot of vibe-coded code bases, which is often more code, faster developed, and developers don't understand these code bases anymore. So they are overly complex. They don't have proper test cases. They don't handle edge cases. Some invariants might be missing. And we then started to encourage protocols to submit test coverage metrics to us before we start an audit. And what happened is some of these vibe-coded code bases, they had 100% test coverage. But they didn't check anything meaningful. They were just covering all the statements, but they didn't do any assertions, any invariant checks, property tests, or something like that. That was checking if the business logic actually does what it's supposed to do. So what this means is that we need to be more efficient, not just in creating code, but also in checking it for security vulnerabilities. And the big question is AI for auditing. Of course, the vision is we have AI agents that are running all the time, ideally integrated in CI pipelines, so you have feedback on your code in real time. There are some examples of this happening already. For example, Google AI's Big Sleep. There was an exploit stopped. There's another one where OpenAI's O3 has spotted a vulnerability in Linux. But let's talk about smart contracts and the Web3 space and how good AI is there today for detecting vulnerabilities. These numbers are not all up to date because we use numbers from research papers. But if you just do single-shot LLM prompting, means you put your code base into an LLM like Claude, ChatGPT, and you try to find vulnerabilities that way, you have around 40% precision and recall. Precision means if you find something that is actually an issue and not a false positive, so that means 6 out of 10 findings from a standard LLM prompt are false positives. And recall means out of all the known vulnerabilities, how many are detected? 40% means, again, that this model is missing 6 out of 10 vulnerabilities in that code base. So standard LLM prompting is good at finding some issues, like well-known issues like reentrancy, for example, and Solidity smart contracts, but they often miss other things. Like in one example, there was a cross-chain MEV exploit right next to a reentrancy issue. Reentrancy was detected, cross-chain MEV exploit not. There are far more elaborate and advanced setups. For example, having multiple LLM agents that compete with each other to find vulnerabilities or to verify them. I listed a few of them, and most of them actually achieve more than 90% recall and precision, which is really good. Like the 40% precision and recall, just using standard LLMs, what I talked about before, that's not enough to actually use them during an audit, because our engineers spend more time weeding out false positives, and the recall is so low that we don't really want to trust them anyway, so we need to review the whole code base in either case. A 90% recall and precision is pretty good. And 90% also outperforms standard static analyzers like Slither, Mithril. They often have also 40%, around 40%. And then there are more advanced approaches using machine learning classifiers, GNN-based detection. There's one example here that have shown in data up to 90%, 99% recall and precision. So the question now is, do we actually need auditors? Like, our job is done. We can now just hand it over to these AI agents. There are two caveats here. Firstly, all of these testings here have been done on Solidity code basis. And the data that's used to evaluate these models is typically only covering well-known vulnerabilities. So there's a data set that has vulnerabilities from the wild, but the wild is still well-known vulnerabilities that have been reported on, have been detected, are well understood. So if we are not in the Solidity space, but in the Rust space, like here, for example, and if we don't just consider data about known vulnerabilities, the picture looks a bit different. So in a summary, AI is great in detecting known vulnerabilities. A quick case study, I don't want to spend much time, don't worry about reading all of this. This is an audit we've done last year of Cosmos SDK. We looked at some of the core logic in Cosmos SDK, and there was one issue, the first one in our report, a critical vulnerability we detected that was easy to detect with today's tools. Back then, we didn't use any tools, but this is something where you have just unbounded iterations. So there is compute exhaustion up to the point where it can cause a DOS attack, a denial of service attack on a node. The second issue from the same report is something completely different. This is an issue where you need to understand the business logic. You need to understand the relationship between different accounts and how authorization between them works. And this is something an LLM-based approach would not have found. A second case study, not from the Web3 space, but from traditional penetration testing, is the XBAU pen tester. That's an agent-based penetration tester that's currently on the spot number 1 on the HackerOne US leaderboard. It filed since its inception in February 2025, 1,092 zero-day exploits, which is phenomenal. Like, it's really amazing. But as before, this is very good in detecting common vulnerabilities and not so great in finding complex new bugs. This picture I really like. This is a lock-picking gun. You can buy that in Germany for 71 euros. Again, great tool. If you have a standard lock, you can open that with that. But if you have a more advanced lock, it doesn't work. So again, same picture, right? Great for known bugs, weak on novel logic. So what we do at Oak Security is we combine human and AI. AI helps us to find common vulnerabilities, replace checklists, replace a lot of tooling, actually. It also helps us in summarizing code bases so we can better understand them. It can help with automating fuzzing, setups, exploit generation, documentation, and reporting. But then everything that's more complex and needs deep understanding of a protocol, including economics, game theory, all of that is handled by humans. And that has actually a huge benefit, and our auditors are great for the AI tooling that's existing today, because main point is the middle one, that we have less audit fatigue. The problem with auditing is if you stare at code bases all day and you try to find critical vulnerabilities, it can be very energy draining, especially if there's a lot of stuff that's not relevant. Like, it's just easy bugs that could have been fixed by proper testing or proper tooling. So we can get rid of all of those and focus on the actual potential exploits that are much harder to understand but much more relevant to our clients, which allows us to either be faster, like cheaper, find the same kinds of vulnerabilities in the same time, and in a shorter time, or have higher coverage and just have less remaining risk after an audit is done. In an ideal world, we would like our clients to run all of these tools before we run them. Like, ideally, we don't even have to run them anymore, but can only focus on complex business logic flaws. But there comes another concern into the game here, which is privacy. Most of the proprietary models today, we cannot really use them because the source code we get is often under an NDA. We often review it before it's open source, so we cannot just take your code, upload it to Claude or ChatGPT and let them do the job. Rather, we are actually running open source models on our own local hardware or on remote desktop setups that are somewhere in the cloud. But that means that it's more complex to set up. So I'm doubtful whether our clients will run all of these tools right now because it requires high-performance hardware and it's difficult and complex to set up. There's another problem which is actually a bigger problem than just AI and code reviews, which is security spans much more than just code and audits, right? Web3 projects often get exploited because private keys are compromised, they hire someone from North Korea maybe, who's just compromising the team, or there's social engineering attack on founders or developers, local machines are compromised, things like that. And security is a cultural thing within a company. It should permeate through your product development lifecycle, through your team, through all the things you do as a builder in the blockchain space, and not just be concerned with code security. As a quick case in point, it's a bit hard to read here, but this is the rect.news leaderboard, which is listing all of the exploits that happened over the last couple of years by the damage that was caused. And we don't need to look into them in detail, but I just wanted to give you an overview here that 6 out of these top 10 exploits are related to social engineering, failing operational security, supply chain attacks, using the wrong cryptographic library. So if we had audited that code, and even with 100% coverage, we would not have prevented 6 out of 10 from this leaderboard list. So what can you do, and what do we advise you to do? We like the concept of a zero trust assumption in security. The idea is that you assume that one of your components in your whole architecture will fail, that employees might be compromised at some point, that developer machines might be compromised, that a founder is hopefully not kidnapped, but I mean, something could happen to a founder, right? And the solution to that is the Swiss cheese model to cybersecurity, where you have multiple measures and multiple things implemented in your security strategy that all have potential holes, so none of them is 100% secure, but you implement enough and layer them on top of each other such that the holes ideally don't overlap. So you can stop an attack, maybe not in the first line of defense, but there's a second one behind that. And this way of thinking about a zero trust assumption and Swiss cheese, it can start at the beginning of your software development lifecycle, at the design stage. So when you design a protocol, you can think about the architecture, about economics. And of course, we can help in any of these stages, but the message is here that in-house, but also with external consultants, you can approach security from each of these stages in the product development lifecycle. And yeah, I don't want to go through all of them. Audits, of course, is our key. Most of our revenue is coming from audits right now, but there's also a lot of measures that you can do in production during operation, like rate limits, circuit breakers. Have been a lot of discussions around these recently. But overarching, we also recently started to introduce virtual CISO services. So if you are curious in how you should set up such a strategy, feel free to approach me. We help with security strategy, training for teams, etc. All right, I'm almost at the end here. Just to summarize quickly, we've seen a lot of vibe coding. I would say probably 1 out of 10 code bases that we see today is so bad and so heavily vibe coded that we need to either reject the client or put in a significant risk buffer just for the additional work we have to invest in order to review that code base. And you can easily detect it. For example, if there's trivial functionality that's heavily documented, it's probably from an AI. But there are other ways to figure out something is vibe coded. So vibe coding increases risks and the attack surface, which means we need AI also in security in order to make us 10x more efficient. It augments all our auditors, also your developers. And third message here is that security should be way more than audits. We should really move away from that thinking of, hey, you get a rubber stamp and you're done and security is taken care of. That's completely the wrong approach. And we would encourage our clients and everyone listening to this talk to think about the zero trust mindset. Like, what could go wrong? And what happens if you assume that any layer of your protocol of your architecture, your team, your DevOps pipeline, any of that is compromised? What will happen then? We do offer free training. There's one scheduled for right after DevConnect. If you want to attend, just scan this code here. It's a 2-hour session for technical and non-technical folks about Web3 security awareness, how to make sure you don't get compromised. There's also our website down there, and please follow us on Twitter. And that's all. Thank you so much for your attention.
Amazing. Thank you, Philip. We have a few minutes for questions. If anybody has a question for Philip. What were we talking about? You said something about how economics is one of the more difficult sort of disciplines to study, and then you said something about how you have to think about how humans work, but then backtrack, and everyone thinks they're right, but then they're really not right. And I'm sure you said it way more articulate than me, but do you remember what you said about that?
Yeah. Brooke asked me earlier what I studied, and we talked about economics quickly. And I said that economics is quite a depressing discipline. It's depressing because you have that model of humans that they are rational, egoistic, that they have perfect information, which is, of course, completely wrong. So you have that kind of conflict in yourself that you know your base assumptions are wrong, but surprisingly, they still explain a lot of behavior in the real world. So they work even though the assumptions are wrong.
Right.
And it's a constant battle between trying to break these assumptions and move away from them, but then realizing, okay, but they are not that bad.
Yeah. Cool. Well, you did great. Thank you so much for being here. Another round of applause for Philip. Yay!
Thank you.
Thank you, Philip.